All right, thank you everybody, and heartfelt thanks to Roger for taking us. I hope you can hear me. Is that all right? Everybody can hear? All right. Taking us on this wonderful journey through IIASA. It's much appreciated, and of course he's one of the few people that can really relay that story the way it should be told. So much appreciated. But we're going to be looking a little bit forward, and I'm not going to spend an awful lot of time. I want us to just go through some of the basic things that are happening at IIASA as best as I can. Roger sketched for us in very engineering fashion some of the issues of systems analysis that we want to tackle. But we also know when it comes to modern policy making and decision making and all the problems that we have to deal, all these global problems and universal problems that we have to tackle, that at the end of the day, the policymaker is faced with this kind of conundrum. And this is what they have to tackle and deal with, which includes all the feedbacks, the synergies, the trade-offs in terms of making decisions at the end of the day. And a large part of the work of trying to resolve a better future for humanity is locked up in the Sustainable Development Goals as we see them today. The Sustainable Development Goals in themselves are a systems problem in terms of actually delivering on the Sustainable Development Goals. And I must say, I get very despondent when I see the Austrian government appoint a professor in the SDG number 6 and a professor in the SDG number 8, because that's not the way we're going to solve these problems. They're all interlinked, they're all connected, and we must take a systems approach to try and move us forward. So IIASA is ideally positioned to try and tackle these kinds of problems, systems, from a systems perspective. So, in a recent paper that I'd refer some of you to, maybe a follow-up on Roger's earlier work, Ulf Dickman and a couple of partners have been thinking about what exactly are the components of systems thinking. And they pulled out 5 interesting points. The first is, first of all, that the general problem is when people draw the boundaries of the system too narrowly. In other words, they exclude the environment, the social environment from their thinking, or usually economic. And then they create these externalities, which have become a problem down the line and they have to be created. So holistic accounting of impacts is important, sorry, long way. And we have to think about the entire system. We must ensure that we think about the feedback loops. This is where the surprises come from, the unintended consequences of implementing policies results in overlooked feedback loops that we ignored. When we have trade-offs and synergies, again, these are usually created or left outside the boundaries of our systems thinking. So in other words, when we ignore trade-offs and synergies, it's because we've defined the system artificially in a way that loses potential benefits from thinking a little bit broadly, or possibly ignores other consequences that may emerge from taking certain actions into the future. Of course, the emergent phenomena problem that we all understand in a systems context. We've just been through COVID. What that's done to society, what's done to our decision making, what it's done to the way we engage and interact. And of course, the human and social dimensions are really important. The Greta Thunberg syndrome that emerges in society and changes the course of the conversation very, very quickly. These are things that are really important. And of course, when you talk about problems that require inputs from many stakeholders, we have to have systems and ways of dealing with many stakeholders to make sure that the decisions are inclusive so that we can actually deliver on the objectives at the end of the day. So just some thoughts from those particular authors. I'm going to just run through those 5 issues for you. First of all, holistic accounting of impacts. This is analysis from the Global Energy Assessment. It's quite old already now, but it just clearly illustrates the consequences of dealing with things in silos versus dealing with them in a systems context. If we deal with only the energy security matter, it costs us about less than 0.2% of the global GDP to resolve that, more or less. To deal with air pollution will be just under 0.6% of the global GDP. Only climate change will be slightly more than 0.8% of the global GDP, but if you deal with them as a system and deal with them collectively, exploit the synergies that emerge from that analysis, you can actually deal with all 3 of them in an integrated fashion and save about 40% of the anticipated cost at the end of the day, because you're thinking about the entire system. So this is some of the benefits that flows from holistic thinking. feedback or positive feedback loops. A very good example that we have from work at IIASA is about the population issues. And this is a very good example of including education as a key driver in your population demographics into the future. This is an Indian population projection looking at sustainable development scenario on the left-hand side and a stall development scenario on the right-hand side, and just clearly demonstrates how education can change the population trajectory from 2.1 billion in the stalled in development scenario to less than 1.5 billion, and with a much larger part of the population actually having gone through secondary education as a consequence of that. So again, the idea of educating people will change the demographic projections of a particular country. This is something that we know and understand, but again, it just demonstrates the positive feedback loops that can emerge. From synergies, technology. Roger told us about that quite a bit, how technology has evolved. You may understand in the middle there is a list of things you used to have in the house. Maybe your dad still has them in the house. Camera, scanner, radio, telephone, alarm clock, pocket player, voice recorder, weather station, all that stuff. That used to consume about 450 kilowatts in order to run those instruments in the average household. On a standby mode, 72 watts. All that stuff in the middle has now been replaced by your cell phone on the left-hand side here, which now requires 5 watts to run and about 2.5 watts in standby mode. So this just indicates to you how the development of technology can actually work together to actually reduce the energy demand side in a normal household. Trade-offs, we understand these very well. This is an example from conservation and from thinking about dealing with the planetary boundaries problems that we have to deal with. We understand the planetary boundaries crisis that we face across the entire globe, but we also understand that the harder we push the planetary boundary conversation, there are going to be secondary consequences as a result of that. And one of the analysis from IIASA clearly demonstrates that as harder you deal with the planetary boundaries matter, there are going to be consequences for food prices. And we have to be aware of that, and we have to deal with it and factor that in our planning. Let's not get surprised by things that may happen because we're trying to achieve something else. Emergence, I've spoken about COVID already, really, really important demonstrator to us the difference of focusing entirely on efficiency as a driver for the design of the global trade system, for argument's sake. And we've now learned that the global trade system has become incredibly brittle as a consequence of its over-focus on efficiency, because there was no resilience in that trade system. And because when we think about systems and building them into the future, we need to make sure that we think about sustainability and resilience at the same time. Efficiency can be part of it, but it can't be the only principle driving our design, because we are going to hit the wall at some stage when some crisis comes by. Stakeholders, multiple stakeholders, again, just an example from the FABLE initiative run together between IIASA and the SDSN network, which essentially from the bottom up is generating information and data related to land use, biodiversity, population issues, consumption, etc., and building that into our understanding of the information required to deliver and measure and monitor the growth and development towards achieving the Sustainable Development Goals. We at IIASA understand that the global system as a whole has to go through some critical transformations moving forward over the next decades. We understand that these are related to achieving the Sustainable Development Goals. But much of our work is trying to look for synergies through the systems approach that we develop there, looking for feedbacks, looking for positive interventions we can make to try and achieve those global objectives at least cost if we can. This is a good example from the conservation area, a project driven by Nature Map, which clearly illustrated that conserving only 30% of the land surface around the globe, we can safeguard 70% of all the terrestrial plant and animals that are included in this analysis, at least it's what we had available. But at the same time, we can conserve 62% of all the vulnerable carbon around the world, and at the same time also ensure 68% of all clean water. So by doing an analysis like this, we can get multiple benefits out of doing a systems review, taking a systems view of what we can achieve. There are, of course, negative consequences in terms of what's happening globally at the moment. The direction of the planetary evolution, driven by the influence, unfortunately, of us and nobody else, is drifting us in this direction, which means that the next generations are going to suffer the consequences of the decisions that we take today. This really interesting work with many partners in the US also involved illustrates how newborns across the globe will face 7 times more scorching heat waves during their lives. They will, on average, live through 2.6 times more droughts than we experienced, 2.8 times as many river floods, or almost 3 times as many crop failures, and twice the number of wildfires as people born 60 years ago. This is unfortunately the trajectory that we've embarked on. This is the trajectory from which we have to pull back. And the challenge that faces us as system scientists is to say, how do we do that in a way that doesn't disrupt the entire society in the process? So we've been working with many people around the world to try and effect change. This is a rather interesting study. Much of our work is focusing on some of these nexus issues. He has a particular analysis in the Indus Valley, looking at land, water, and energy, and just demonstrating the trade-offs and the synergies that exist about decisions upstream, downstream, using resources for energy, what that means for agriculture, what that means for water provisioning down the system, and have a complete picture about the spatio-temporal consequences of those decisions that could be used and implemented by the authorities involved in this particular study. I'll get back to that later. Rather interesting work. We at IIASA are putting a lot of focus on understanding inequalities around the globe at the moment, where they come from, how to deal with them. One of the things, of course, is how we measure them. This is a rather interesting study that looks at the night lights that you all know so well, but we're not looking at the night lights, we're looking at the dark spots. And what we're actually doing from that is to actually get a sense of what that means in terms of the distribution of poverty around the world. In other words, how does that relate to the lighted areas? And it's really interesting that you can actually do a finer scale study like the one in Nigeria that I've just put up there, where there's a very strong relationship, at least a correlation between income index and unit settlements, the percentage of human settlements in particular areas, or unlit human settlements. In the economic side, we've launched the new Economics Frontier program. We're trying to take a different angle to try and deal with these issues. You know, you've seen all the economics models that are out there, the stuff that people use for daily planning and for national planning. You know some of the weaknesses, their ability to take parameters and average them out across households and average them out across the units that they're analyzing. There's a particular statement by Farmer and Foley from 2009, which is quite recent, indicating that we could, if we wanted to create an agent-based economic model, to make useful forecasts like climate modeling, a huge undertaking, they say. Well, IIASA has done it. Okay, we've done very well in this space. We just developed, together with the Bank of Canada, an agent-based model that includes 350,000 agents and includes at least 13,000 firms as agents. In other words, agents are households in this regard. That's essentially how we deal with them. And we could apply that model to a number of normal standard economic questions that get asked by the development banks around the world. And our model outperforms the standard models used by the Canadian Bank. But of course, these have to be developed right around the world for every country, for every agent. But the benefit that you have of this model is that it allows you to deal with heterogeneity within the landscape, so that you can understand when the issues emerge about flood damages that occur in particular areas, you know you have geospatial reference in terms of these households that are affected versus those households. And you don't have to deal with the average problem at the same time. So it gives you significant benefits, planning, responding, and dealing with economic crisis. So IIASA is doing some excellent work in that space. We're also working with the World Bank to develop a one water methodology. In other words, it will be applied across the globe to assess what's happening as a standard benchmark or internal benchmark, if you like, across all the nations of the world and that can be used to evaluate and compare their performance over a long period of time. We continue with our work in climate as an institution. This is the IPC6 assessment reports that have come out. Those are the IIASA people involved. You can look at the slides later if you want to see them. We've also been involved in some rather innovative projects around the use of machine learning and AI. This is the user combination of crowdsourcing to interpret satellite images about the human disturbance in satellite images in tropical forests. And then we used that data set that we got from the crowd, it was interpreted by the crowd, to actually train an AI that then eventually starts doing this automatically. So what we're moving towards is looking at land use, land change monitoring in a way that becomes near real time. That's what we're after and trying to achieve in this regard. Our systems are too slow. By the time we pick things up, they've already developed a mind and a standing, and then you're not going to change it. Okay. So close to the end from my side, I want to just touch on the issue of science diplomacy. In the context of where we are now, Roger explained very clearly why science diplomacy is in the DNA of IIASA and is part of the institution. We now face some crises at the international phase, which is really important. The Ukraine war is precipitating an environment where many of our member organizations are considering the membership of IIASA at this point in time, which is completely and clearly understandable. But I think if you think back about the roots of the institution and what it stands for, we must contemplate that there will be a world after the war eventually. And eventually in that world after the war, IIASA, science diplomacy, building bridges between communities must be a key part of our message moving forward. We use it in very strange places, like that study I showed you earlier about the Indus Valley, where at that point in time when the study was on the go, it was the only contact between two governments, Pakistan and India. Two ministries engaged in this process. It was the only platform they had to communicate and talk about issues of mutual interest and common interest. Just demonstrates the value of science diplomacy under very difficult circumstances, and that how important it is to get conversations going moving forward. And then I want to go back to the IIASA Charter of 1972. Let's not forget what was in the Charter. First of all, it says that convinced that science and technology, if wisely directed, and can benefit all mankind. Believing that international cooperation between national institutions promotes cooperation between nations, and so the economic and social progress of peoples. Hereby resolve to establish an international institute for applied systems analysis. IIASA has lasted for 50 years, and I hope it's going to last for another 50 years at least. Thank you very, very much.